Hi everybody, welcome to the Unit 4 test review. So on these first couple questions we need to determine whether the triangles are congruent, and if they are, write the congruency statement and identify the postulate, so one of our big 5 statements. If not, then we'll write not possible. On this first one, it looks at first like we don't have enough markings, but if we remember that we can throw in these vertical angles being congruent, then when I look at each triangle I see they have an angle, a side, and an angle. The other one has the same angle, side, and angle. So ASA is the postulate that I'm using to prove the triangle is congruent, and then the congruency statement is just when I'm labeling like triangle blah 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 congruent to triangle blah blah blah. Here it looks like A and D have the same number of markings, so I'll put those in corresponding positions. They both have angle B, and then the other angle over here is C, the other one over here is E. Cool. Now let's move on, look at number 2. So I see an angle, and a side on this triangle. Oh, snap, but over here, the markings aren't matching up. I've got A, and then the S is included. So this is one of the none, or not possible examples. Markings didn't match up. Alrighty, looking at number 3. I see a side, an angle, and a side. On the first triangle, the same side, angle, and side on the second triangle. So that is our SAS, or SAS postulate. Congruency statement. Let's see. A, B, C is congruent to triangle D, E, F. Cool. Next one, number 4. When I look at these two, it looks like all their angles are in common, but that's actually not one of our theorems. Those are similar triangles, but not necessarily congruent. So this is another not possible or none. Impossible. Go back up to the top. When we look at number 5, I see they both have sides with these little 2 markings on there. They both have a side with one of the little 1 markings on there. So right at first it looks like maybe not enough information, but we have to also think about these little triangles, which mean we have parallel lines. And from our unit on parallel lines, I know that I would be able to maybe mark these 2 corresponding angles. But that angle right there isn't one of the angles of the triangle. It's not A, B, or C. So on this one, it looks like we just aren't going to have enough information to have congruent triangles. But I did have to kind of think about what effect those parallel lines would have. Alrighty. When I look at these, obviously they're going to share that side BD in the middle. So I see side, side, side on one triangle, side, side, side for the other one as well. So postulate, S, 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 congruency statement, triangle A, B, D. There's one of them. Here's where things get weird. A matches up with C. And then on A, B, D, B was in between the one with 1 mark and the one with 3 marks. So the one with 1 mark and the one with 3 marks over here, that would put me at D, and then B. Next one. Angle, a side, and a side. Oh snap, oh snap. I don't want to end up accidentally cursing, but I'm lucky. This is a right angle, 90 degrees, and so is this one. So here I've got a hypotenuse of a right triangle and a leg. Over on the other guy I've got the hypotenuse with the same number of markings and also a leg. So this guy is going to be HL. Whoop. Let's maybe just draw some arrows here. Congruency statement. M is the right angle on that triangle. Q is the right angle on the other one, then L goes along the leg, O goes along the leg that's marked, and then finally N and P. Cool beans. And then on number 8, let's see, I've got, oh, this is kind of same sort of deal. An angle, a side, and a side. That's not a theorem, but we're lucky we've got right triangles, so we actually have hypotenuse and a leg, hypotenuse and a leg for each of those two. So triangle ABC congruent to, let's see, F corresponds with A, and then I went D, and the right angle would be last. You could have yours in another order, by the way. Like if you had triangle BAC, that would be totally cool, as long as you also had then triangle DFE. Because like notice E is a right angle, C is a right angle, so they've just got to be like in matching parts in your congruency statement. Alrighty, feeling pretty good. We're going to move on, take it up a notch. So what additional information would be needed to prove that triangle ASE is congruent to triangle ECA by side, side, side? Alrighty, cool. So let's talk about first, we already know that they have one side in common. They also are going to share this middle side. So the only ones that we still need are these guys that are off to the side. We would need AS congruent to EC. Notice that putting the little markings on there isn't enough for me to answer this question. You've got to actually write out the thing that you would need. And we want to try to just have one extra piece of information that's needed. You don't need to write AE congruent to itself because we already know that. We already know that they have this shared side. And that applies on number 10 as well. We want to use hypotenuse leg to prove two triangles congruent. So I already know that they have this hypotenuse in common. I've already got that just from the drawing. I've already got the right angle just from the drawing. So they just need to have a leg in common. And here there are two different options. You only need to write down one. So if you decided, oh, I want the two shorter legs to be congruent, then you would say that you need QS to be congruent to RT. And you're done. You can go ahead and do number 11. The other option that somebody might have put, you don't need to write both of these, you would just need to write one, is you could have like the top and the bottom, QR congruent to ST. And that would be another perfectly acceptable answer. Alrighty, what extra information would be needed to prove these two triangles congruent by ASA? Alrighty, so I've already got an angle on each one. I've already got LK, the side in the middle. So then the other angles that I need would be the ones that make that an included side. So I would need those two guys that I marked with the double hoops. But again, the marking isn't enough. You've got to say, exactly which angles. I can't just say angle K either, because angle K could mean that or that. Either one of those two. So I'm going to have to use 3 letters. Remember, I'm labeling the ones with the double hoops. Those are the ones that I added in. The others I already had marked. So I would need angle LKJ to be congruent to angle KLM. And then I could use ASA. Alrighty, a couple more of these. What extra information would be needed to prove the triangle is congruent by AAS? So I've already got AS for both of them. To make sure that it's angle side and not angle side angle, I'm going to want to pick the one that's kind of off to the side. If I picked X, that would give me ASA, which is not the theorem I want to use. So over here I'll want to use G. So I would need angle G congruent to angle Z. Alright, what extra information would I need to prove the triangle is congruent by SAS? Alright, so I already know TX and XZ are the same. I already know those two vertical angles are the same. If I want to use SAS, I've already got a side and an angle. I need another side. And I want to make sure I pick the right one. I want SAS, SAS. So I'm going to want to pick the two sides that I just circled. I'm going to want to add in that XY is congruent to XW. And then I would have SAS on both of them. Cool, moving right along. Given the figure below, how do we know that AB is 9 centimeters? Alrighty, well, let's see. I've got these two triangles, and I see that they're right triangles, and I've got a leg and a hypotenuse that they both have in common. So by hypotenuse leg, triangle ABC is congruent to triangle DEF. Cool, so I know that the triangles are congruent now because I used one of my big 5 theorems. So after that, I can go back and say, alrighty, if those two triangles are the same size or congruent, then any of their matching parts, like DE and AB, have to be the same size. So DE is congruent to AB by CPCTC, which is our theorem that says corresponding parts or matching parts of congruent triangles are congruent. I'm abbreviating a little bit. Alrighty, so we knew the triangles are congruent, so that means all their matching parts have to be congruent. So since DE is 9, then AB is also going to be 9 centimeters. Alrighty, now we're going up to the overlapping triangles. In the figure, it is given that PN is congruent to OQ. State the congruent triangles and the theorem that proves them congruent. Explain how you know angle ONP is congruent to PQO. Okay, that's a lot, so let's maybe just take this one step at a time. We want to be able to say what triangles are congruent. It's kind of hard to see when it's all like mushed in here all together, so my recommendation would be let's draw the two triangles we see out separately. So like I see triangle NOP, which I'm making bold right here, NOP, and I also see OPQ. OPQ. Hint, hint, if you were having a hard time seeing which two triangles, they kind of tell you just in the directions, like, oh, you're going to be looking at angle OMP and angle PQO. So, like, each of those would have to be parts of a triangle. So that could be another kind of hint, another way you look. Let's add some markings in. We know that no and PQ are the same size. Also, both of those two triangles have this side, OP. Not for Osborne Park, but for that side of the triangle. Cool. And what else might they have in common? Let's see. Oh, in the directions. I forgot about this. PN and OQ are the same, so I better mark that. PN and OQ are the same size. Alrighty, so I've now thrown in all my given information, and when I look at those two triangles, they both have all their sides marked. So triangle PON is congruent to triangle OPQ. Q by the side theorem. Since we've proven the triangles are congruent, now we can go back and say by CPCTC, any matching angles, like ONP, that one, and PQO, that one, would have to be congruent. Cool. Alrighty, next one. Complete the congruent statement below. We've got I, G, H. It's talking about this middle angle. I, G, H, then I better go U, G, T. So I, G, H, I goes with U, G goes with G, and H goes with T. So I got that rather than looking at the picture, just by looking at the congruent statement. I can do the same thing over here. If I know that these two triangles are congruent and I want to see what's congruent to TV, then I would look at CU. Alrighty, write a congruent statement for the triangles given below. So triangle blah 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 congruent to triangle blah blah blah. Let's see. A has one little marking. Over here, C has one little marking. Then C has 2, A has 2, and then B has 3, Y has 3. This one, same thing. Whoop. So let's maybe start with T. Both have one little mark. V has 3 little marks. G has 3 little marks. And then U and H are the other angles. Proofs. It's not too bad. Remember, start by putting all your information in the picture. So AB and DB are the same size. There's AB, there's DB. C is the midpoint of AD, so if this is right in the middle of A and D, those would be equal sizes, and then they share that guy in the middle. So already just from putting the pictures, or putting the markings in the picture, I'm thinking I'm going to use side, side, side at some point. Alrighty, so I've got my given information. Since C was the midpoint of AD, that was also something that was given to me. AC and CD, the reason that I put those one little markings in there is because C was the midpoint, and midpoint split things into 2 pieces. So that's just me using the definition of a midpoint. BC, something being congruent to itself, that's reflexive property. I think about like mirrors and seeing my reflection. And then the last one, when I'm proving triangles congruent, I want to use one of my big 5, and I see over here 3 sides marked on both of those triangles. Ooh, overlapping, grossness. If it's hard for you to see, then maybe use different colors, or maybe draw the triangles out separately. I'm going to make one of them red, and then maybe make the other one blue to kind of help me see them, see what's going on. Somewhere where I'm going over myself, like here I see I'm using angle N in both triangles. Again, if you wanted to, you could totally draw these 2 out separately, and that would be totally, totally cool. Alright, so I'm given that NKL is congruent to NJM. So NKL is this guy up here, and NJM is this guy up here. Like I said earlier, they both have angle N. Okay, so I put that in my picture. I also know that KL and JM are the same. So KL here, JM is here, and then it looks like I'm going to be using like angle, angle, side on these guys. So let's start our proof. The first part is a given. KL and JM, that was also in my given list. Something being congruent to itself is going to be my reflexive property. The two triangles are congruent. By looking at the picture, I see angle, angle, side, angle, angle, side on both of them. So I'm using one of my big five to prove triangles congruent. And then the last thing, now that I know these two triangles are congruent, I can go back and be all like, oh, cool, then this little short side and this little short side have to be the same length. So that's me using CPCTC. Alright, so that's it for triangles. The very last couple questions are us just reviewing distance, midpoint, and slope from a previous test. So you're going to need to use your formulas on these. Length, remember, is just another fancy word for distance. So I'm going to be using my distance formula, plugging in some x's and y's. So let's do the difference of my x's first. I've got minus 2 minus 4 squared plus 3 minus 6 squared. So negative 2 minus 4 would put me at negative 6 squared. Notice the parentheses. Parentheses save lives, people. 3 minus 6 is negative 3. Squaring that. And then when I square anything, these negatives turn into positives. So I would have 36 and 9 under my little square root house. When I add those two together, I end up with 45. Square root 45. And you could leave it like that, or you could type it in your calculator and give me a decimal answer. Let's see, the closest perfect square to 45 is 36, so this is going to be like 6 point something, close to 7, as our final answer. And it makes sense because lengths or distances should be positive. Slope, I'm going to plug into my formula for slope, rise over run. So I've got y minus y over x minus x. Notice since I was doing 4 minus a minus 2, I put some parentheses in there, and that's going to turn into addition. So like 6 minus 3 is 3. 4 minus a minus 2 is like 4 plus 2, which is 6. And then I'll reduce my fraction to get a half. Midpoint, I'm going to do my x's added together, divided by 2, and then my y's added together, divided by 2. So that's 2 over 2, which is 1, and this would be 9 over 2, which you can leave as a fraction, or you could turn 9 over 2 into 4 1/2. Alrighty, next one. If the end point is negative 2, 4, and a midpoint is 2, 1, where's the other end point? So I'm going to draw myself a little picture. Midpoint would go in the middle. I'll put the negative 2, 4, one of my end points, on either side, doesn't really matter. And then I'm trying to figure out what's going to be over here in my final answer. So like to get from negative 2 to positive 2, I have to add 4. So I'm going to do that over here as well. Add 4. 2 plus 4 is 6. To get from 4 to 1, I've got to subtract 3. 4 minus 3 gives me 1. 1 minus 3 gives me negative 2. So that's my final answer there in the circle. And on number 23, graph the line y equals 3. Y equals would give me a horizontal line. So here, right there, this dot is at a y value of 3, and I'm just going to draw a horizontal line through it. The slope is 0. For vertical lines, we've got an undefined slope, and they are an x equals equation. So the slope is going to be undefined. And then if x is equal to negative 2, there's an x value of negative 2. I'm just going to draw, whoa, guys, drawing straight lines is hard. I'm just going to draw a vertical line Oh, it looks more like a, I don't even know. Struggle is real, guys. You get the idea. Vertical line through x equals -2. Alrighty, last two. Write the equation of a line that's parallel to that line that goes through the point 4, 6. Alrighty, so when I'm writing equations to lines, I know that I want my final answer to look like y equals mx plus b. And if I want a parallel line, then I know I want the same slope as that one. So I'm going to put the same slope in there. I just need to figure out what my y-intercept is going to be. Now, some teachers do this different ways. So some teachers have taught point slope form. What we're going to do on this one, though, we're going to use this other piece of information that we're given. We've got an x value and a y value, so I'm going to plug those in for x and for y and solve for b. So order of operations, I'm going to end up multiplying first. And I'm going to extend my page a little bit. So 1/2 times 4 is 2. And then if I subtract 2 from both sides, I get that b equals 4. So that'll be what I stick in my blank. Over here, I've got a similar problem, but this time I'm writing the line perpendicular. So again, writing the equation of a line, y equals something x plus something. If I want a perpendicular, then I want the opposite reciprocal slope to -1/3. So the opposite reciprocal of -3 is positive 1/3. And again, I just need to figure out what's going to go in for my y-intercept by plugging in my point. So 1 is the y value, -6 is the x value, and I'm trying to find b. 1/3 times -6, you can do that in your calculator if you need to, should give me -2. I'm going to add 2 to both sides and get that b equals 3. So that'll be what I put in my blank up there, and those guys that are circled are my final answers. Again, if you have questions, bring them with you to class on test day or stop by office hours.